Welcome to This Explainer. If you've ever actually stopped and marveled at how tools like ChatGPT can just effortlessly write essays, or how modern vision models can instantly analyze incredibly complex photographs, well, you are in exactly the right place. Today, we're going to completely demystify the magic under the hood of modern AI. We're going to break down the exact architecture that makes all of these incredible feats possible, and we'll do it step by step. Let's dive in.
Right off the bat, I want to pose this central question to you. How did one single, highly specific mathematical shift back in 2017 completely revolutionize the entire artificial intelligence landscape? Before this breakthrough, progress in AI was, steady, but it was highly fragmented. Text was handled one way, images were handled in a totally different way. But a single architecture changed all of that. Today, we're looking at the exact blueprint that made this all possible.
Section 1. The AI Sequence Bottleneck. Okay, so let's understand the problem first. Older models for text, like recurrent neural networks, had to rely on sequential processing. Basically, they had to read data one single piece at a time, very much like how a human reads a book. But this meant they had really poor global context. By the time they got to the end of a long paragraph, they'd essentially forgotten what the first sentence was even about. Plus, because they processed step by step, they just couldn't take full advantage of fast modern computers. The transformer, it flipped this entirely. It processes data in parallel, maintains excellent global context, and runs incredibly efficiently on modern hardware. Think about reading text like an old-school ticker tape, one single word at a time, kind of like a line of dominoes falling over. That was the old way for text. And for images, AI viewed pictures through this localized sliding window, literally just scanning tiny chunks one at a time. Both of these methods are serialized, they're bottlenecked. The transformer, however, doesn't do step by step. It's this highly connected, parallel web that looks at everything all at once.
Part 2. The Attention Breakthrough.
This brings us to 2017. A team of researchers at Google published a now famous paper with a great title, Attention is All You Need. And it proposed a radical simplification. They argued that AI didn't actually need those slow, step-by-step loops or sliding windows anymore. Instead, the architecture could rely solely on something called self-attention to instantly connect inputs and outputs in a super clean, highly parallelized structure.
So let's define exactly what we mean by an attention mechanism. Honestly, it's pretty much what it sounds like. It's a technique that allows an AI model to evaluate an entire sequence of data simultaneously and mathematically prioritize or attend to the most relevant parts. Think about how you process a crowded, noisy room. You aren't scanning every single millimeter with equal focus, right? You attend to the faces, the voices, maybe a sudden movement. The transformer does this exact same thing, just with data.
Take the phrase, the bank of the river versus the bank on the corner. The word bank means two completely different things in those sentences. Because the attention mechanism is looking at the entire context simultaneously, it draws mathematical connections, which we call attention weights, connecting bank really strongly to river on one side, but connecting it to corner on the other. It captures that global context instantly, which gives the model true semantic understanding.
Section 3. Queries, Keys, and Values.
Now, before we get too deep into the weeds here, let's pose the really critical question. If a machine is just doing math, how does it mathematically score what is relevant and what isn't? How is it actually assigning those connections we just talked about?
Think of it literally like a giant filing cabinet system. When a word or a token enters the model, it gets mathematically split into three distinct parts: a query, a key, and a value. The model then uses these three components to sort through the entire database of the sentence to find exactly what information is most relevant to the current word it's processing.
To break that down simply for you, the query is what a word is actively looking for. The key is what every other word says it is. The AI mathematically compares the query of one word to the keys of all the others. If there's a match, boom, it gets a high score. It turns those scores into percentages, applies them to the values, which is the actual content, and the result is that the AI instantly zooms in on the most critical information without having to read it in a strict order. Pretty brilliant, right?
4. Seeing images as words. Fast forward a bit to 2020. We've conquered text, but researchers asked this bold, honestly almost crazy question. Could this exact same attention math, the queries, keys, and values, be applied directly to computer vision? Like, could we completely bypass the old networks that read pixels in a grid and instead just treat pieces of an image exactly like words in a sentence?
Well, the solution they came up with was beautifully simple. It literally just takes 3 steps to turn a standard photograph into a format that a text-based transformer can read. First, you split the image into fixed-size square patches. Second, you flatten those patches out into a single line, almost like a string of text. And third, you feed that resulting sequence straight into the standard transformer. When you look at this process, the AI chops an image, say of a building, down into a grid of distinct square patches and essentially flattens them into a single horizontal sequence. So as far as the AI is concerned, that patch of blue sky, that's just a word. The patch of the window? Another word. The street? Yet another word. It is quite literally reading the image as a visual sentence.
And because of this, the Vision Transformer instantly casts attention threads across the entire image from the very first moment. It immediately isolates exactly what matters, like a dog's fur, its face, its body, while completely ignoring the dark grass in the background. It connects the visual pieces globally, exactly the same way it connected the word bank to river in our earlier example.
5. The Universal AI Engine. So, here is the ultimate realization of this breakthrough, and what you should really take away from this explainer today. This one mechanism shattered the historical boundaries between entirely different types of data. Whether it's processing linguistic words like "the dog caught the ball" or visual patches of a photo of a dog playing fetch, they all flow into the exact same engine. The model doesn't care if it's reading English or reading a JPEG. The architecture is identical.
I absolutely love this quote from our source material because it just perfectly summarizes the whole revolution. Attention is medium agnostic. The underlying math of query, key, and value, it's universal. The transformer is no longer just a text tool. It's a universal pattern recognition engine where scale and data consistently outperform older, highly specialized engineering. It's a real game changer.
So I'm going to leave you with this final provocative thought to ponder today. If this single, elegant architecture has already conquered both human language and computer vision using the exact same underlying math, what hidden patterns in our world will it unlock next? Audio? DNA sequences? The possibilities are quite literally boundless. Thanks so much for joining me on this explainer. Keep learning, and I will see you next time.